All right. Now let's look at problem number 8. Okay, so number 8 says Jasmine keeps adding numbers one by one from the list, right? So those are the collection of all odd numbers. All right, so then at some point she got number 379, and she found she missed a number in the process. Okay, so the question, what is the missing number? Now, so here's the key point. The key point is if we look at this, the sum of consecutive odd numbers starting from 1, you find they're all squares. So we have 1 plus 3, which is 4. What is 4? 4 is 2 squared. So 1 plus 3 plus 5, which is 9, so which is 3 squared, right? And if we have 1, 3 plus 5 plus 7, so this is the sum of 4 consecutive, the first 4 odd numbers. So this is 16, which is 4 squared. All right, so basically here we have the following rule. So this can be verified by Gauss trick. The sum, okay, the sum of the first n odd numbers equals to m squared, right? So this is the sum of the first 2 numbers. This is the sum of first 3 numbers. This sum of first 4 numbers is 4 squared. So the point is like, okay, so if everything goes correct, this should be the sum that Jasmine obtained. Well, but here says at some point, she obtained the sum is 379, and we see 379 is not the square of any number. So we're trying to find like which number is missing. Okay, so we need to give an estimation, like which one is kind of close to 379, and we find it's 400, right? 400, which is 20 squared. If we go up, that will be too large because she only missed one number, right? Okay, so if we're below 20, that will be a small, right? So that will be smaller than 379. All right. Okay, so then here what we have, we get, this is 400. So let's see the difference. So the difference is 21. So we get the missing number is 21. So 21 is missed. Okay, so 2 plus 1, which is 3. If we try to, let's recover the whole picture. So basically up to the point, so 1 plus 3 plus 5 plus 7, and then all the way to the 20th odd number. So this is the 20th odd number. That is 39. So if you add all those things together, you should get is 400. So nevertheless, in the point, somehow this is 21, which is in the middle. So this guy is missed, right? So if this guy somehow is missed, then you get is 400 minus 21, that's 379. All right. Okay, so here the key point is you should realize the sum of those consecutive odd numbers is just the m square, is the square of the number of odd numbers. All right, so then you give estimation. You find 400 is near this 379, so it's bigger. It should, of course, should be bigger, which is 20 squared. Okay, now let's look at problem number 9. So here we have two-digit numbers. That's AB minus CD is 24. And then we have 2 3-digit numbers. 1AB minus CD1 is 15. Okay, so clearly, if because this one minus 1 is 5, so we get B is 6. So we get B is 6 right here. And then B minus D, in order to get a 4, then D has to be 2, right? Okay, so we get D, this one is 2. All right, now from here, so if we look at C, if we look at C, so C has to be 1, right? So then, well, we just want to get this to be 0. All right, so this is 1. Okay, now C is 1. Then A minus 1 is 2, so we get A equals 3. So we get A, this one equals 3. All right, so we summarize. We get A is 3, and the D is 2. So D is 2. So D is 2. So A plus D equals 5. Okay. Now let's look at a problem 10. So problem 10 is travel problem. It says we have the speed of train is 15 minutes per second. So that's the speed of the train. It takes the train 10 seconds to pass a lamppost. So this, let's say this is lamppost, and we have the train. 10 seconds. to pass let me write joy. So here we have the train. So 10 seconds to pass the lamppost. So this is the head, this is the head. Okay, so 10 seconds. And then the question is, if we have a tunnel, so this is the tunnel. Tunnel is 300 meters. And then we have the train, right? So we have the train is right here. Say this is the head of the train. Now I want the train to completely pass the tunnel. So it's right here. All right, now you see the travel distance to pass the tunnel is the tunnel itself 300 plus the length of the chain, right? So we just need to figure out the length of the chain. So we need to figure out. So here we need to, the key is to find the length of the train, right? How we find the length of the train? Because here says it takes the train 10 seconds to pass the lamppost, which is exactly the length of the train. So let's recall our general formula. So the formula says this: the time equals to distance divided by speed, or we say similar speed equals to distance divided by time. And this is the same, says the distance equals to speed times time, right? So if I know the speed of the train is 20 minutes per second, and it takes the train 10 seconds to pass the lamppost, which is exactly the length of the train. So I get this one is 10 times 15, which is 150 meters. All right, so I get the length of the train is 150 meters. Okay, so this is 150. So we get the distance from here to complete pass. This is 300 plus 150. That is 450. Okay, so then the time will be equals to 450, and then divided by the speed. The speed is 15 meters per second, right? So the distance, that's 450, and speed is 15. So okay, so we got this 30 seconds, right? 30 seconds to pass the tunnel. So here the main point is you should be careful. For a train to complete pass the tunnel, it needs to pass the tunnel and plus the chain itself, because head in and the tail out, right? Tail out. Right, so you need to figure out the length of the chain. How to figure out the length of the chain is based on right here. It takes the chain 10 seconds to pass the lamppost, right? So lamppost is just one pole. Okay, so that's how we figure out the length of the chain, right? So the length of the chain, which is 150 seconds, 150 meters. Now let's look at problem number 11. So problem number 11, we need to find pairs of integers x and y such that these two fractions they are the same. So there are different ways to solve the problem. The quickest way is we use algebra, but that algebra is beyond the current level. So we'll just go with the brute force. So what we do is method. We go with the brute force. Now, what's the brute force? Because if I have 3x over 3 equals 4 over y, now you see the right-hand side, this one, so 4 over y is at most, because if y is 1, so it at most is 4. It cannot go beyond 4. So that means all possible x is this one, right, is at most 4. So I get x is, all the possible values of x is 1, 2, 3, 4, 5, 6, and all the way to 12. So let me draw a table. Okay, now let's problem number 11. So here we are looking for pairs of positive integers, x and y, such that this fraction x over 3 equals 4 over y. Okay, so there are different ways to solve this problem. So one way is we use the brute force. So method 1 is we just use brute force. So brute force is if you have x over 3 equals to 4 over y, and we know this guy, if you look at the right-hand side, this one is at most 4 because y is at least 1, right? So we know this one is cannot go beyond 4. Okay, so if I have x over 3, so this fraction, it cannot go beyond 4. I get x is at most, right? X cannot go, x divided by 3 cannot exceed 4. Okay, so we know x is at most 12. So x is found from 1 to 12. You just go through different numbers from 1 to 12, and you find those numbers that work. Okay, so that's this is the brute force. Now I will go with one that I use algebra. So this I'm going to use algebra. Okay. So how we do algebra? All right. Okay, so I have basically I get x over 3 minus 4 over y equals to 0, right? You got two fractions that are the same, so the difference is 0. Now, how we do the difference between two fractions? So what we do is we try to convert them into fractions which have the same denominator, right? Okay, so let's do that. All right. So I have this x over 3. I try to convert, this is 3 times y. And then, of course, I need to multiply another y because then y can be canceled, right? Y can be canceled, so it's the same. All right. So the point is this one equals to x times y and 3 times y. Okay, so I change this to 3y. Now, similarly, I can do for 4 over y. Okay, so I can do 4 over y, which is, I just multiply by an extra 3. Okay, so here is also 3 multiplied by 4 because 3 and 3, they cancel with each other. I get a 4 over y. All right, so then for here, I get this one equals 12 over 3y. All right, by doing that, I get this equals xy over 3y and minus this 12 over 3y equals 0, right? Equals 0. Now, good, because we have the same denominator. So I have this one equals to 3y, xy minus 12 implies this one is 0, right? Okay. Right, so after you have the same denominator, then you just combine two fractions. Okay, so in order for this one to be 0, you say, all right, so I just need the denominator, this guy to be 0, right? So I deduce x times y equals to 12. Okay, so then all you need to find is two pairs of integers, partial integers. The multiplication is 12. Then we have there 8, right? So there are 8. So 8 pairs. We have 8 pairs. Because here the order matters, right? We have 1 times 12, 12 times 1, 2 times 6, 6 times 2, and then of course we also have 3 times 4 and 4 times 3. So there are 6 pairs of x and y. All right, okay, so then we get 6. So here my point is there are two ways to solve the problem. One way, the first one probably I think the majority of you probably use the first one, just do the brute force, right? So you realize the fraction cannot go beyond the 4, so that x cannot go beyond 12. So you just try each number from 1, 2, 3, all the way to 12 to find those numbers that work for you. Now, okay, so method 2 is we go with algebra. So this is a little bit advanced, right? So what we do is, essentially it's the same. So the only difference between algebra and regular numbers is we just pretend, we just work with letters. So let's pretend those letters are numbers. So here we say, okay, now I have two fractions. I want to find the difference. How we find the difference two fractions? We first convert them to fractions with the same denominator. Then we can combine them, right? So here's what I did. I combined both of them to two fractions that has the denominator 3y and 3y, right? Okay, so that's what I did. Now, so then I can combine them into one fraction, and therefore the two fractions are the same. Is equivalent to say x times y is 12. And from here, we can quickly figure out those variable pairs, right? Okay. All right, now let's look at the problem 12. So here we have a circle that's evenly divided into 12 pieces. And here are two triangles. You want to find the angle x plus y. Okay, because it's equally divided into 12 pieces, then we know, of course, that each section, this is 30 degree, this is 30, this is 30, this is 30. So okay, so we get this one is 120. So okay, we get this one is 120, right? So we get a 120. So let me erase that. Maybe let me put this. So each one, this is 30. So I get this is 4 pieces. So this is 120. Okay, so then because it's isosceles, right? These two they are both radius of the circle isosceles. So the two angles are the same. So I get this is 30. This is also 30. Because for a triangle, as we said several times, for a triangle, the sum of angles is 180. So I get is 30. So maybe let me remind you. So if I have a triangle, this is 1, this angle 2, this angle 3. So angle 1 plus angle 2 plus angle 3, this is 180. And then if I have a triangle, the two sides are the same, then we have the two angles are also the same. This is called the isosceles triangle. All right, now let's look at this. Here we have 2 pieces, right? So that means this guy is 60 degree, right? It's 60 degree because you can divide into 2 pieces, right? Into 2 equal pieces. Okay. Now, so then we have 60, and because these two sides, they are the same, so I get this one is 60, I get this is also 60. Okay, so as conclusion, we derive the x, we get x equals to 30 degree, and then we have y equals to 60 degree. Okay, so then x plus y equals 90 degree. All right. Okay, next, let's look at problem 13. Problem 13, what we need to do is we basically need to factorize the number, right? So here we have a number 360. We want to write this number as the product of prime numbers, right? Okay, so what do we do is solution. Okay, so what do we do is, there are 2 ways to do. So method 1, we just do directly, so 360. So this one, okay, this guy is this multiplied by 10, right? 36, I say, okay, so this is just 6 times 6, and then times 10. I can further write 6, further factorize this. Each one is 3 times 2. This is 3 times 2. This is 2 times 5, right? 2 times 5. Okay, so then finally I end up with 2 times 2, so 2, 2, 2 times 2, 3 2s. And then I have 3 times 3, so it's then it's times 3 times 3. And then I have the last one is single 5. All right, okay, so then I just times 1 5. Okay, so for this, we use powers. So this can be written as 2 to the power 3, and times 3 to the power 2, and times 5. Yes, of course, the power is 1, right? So if we combine this is the x, and this is the y, and this one is the z. Okay, so I have x plus y plus z is 3 plus 2 plus 1, which is 6, right? So this is method 1. We just do direct factorization. Now, another one which is more popular to do the factorization is we do long division. So let's do method 2. Okay. So method 2, this is called long division to factorize, right? Okay, so we have 360, right? Okay, so what I do is you can start, you can say I start with 2, right? Because this is even number. This is 180. Now I can also read 2 because let's just state with prime numbers. So okay, so I can get this 90, and then 90 divided by 2. This is 45. Okay, so 45. You see, it's a odd number. I can no longer use 2, but I realize this is multiple of 5, so I can do 5, and then I get 9. Right, 45 divided by 4 is 5 to 9, and then I divide it by 3. So this one is 3. Okay, so now you see if I look at on the side, so it's 2 times 2 times 5 times 3 times 3. So I can conclude from here 360. So this is equals 2 times 2 times 2 times 5 times 3 times 3. So we just recover the previous conclusion. So 3 to the power 3 3 to the square, and 5 to the 1. It's the same, right? It's the same, okay? So then this is x, this is y, and this is z. All right, so the point is we have different ways to factorize number. One is if you find this simple, you can do it directly. And the second one, which is more standard, is we use this long division. So each time you just slow prime number, right? If you quickly see which prime number is the factor of it, you just use this prime number to reduce the whole thing. So this is called long division. All right. Okay, so now let's look at problem 14. So problem 14 is we need to calculate the area of the shaded region. So for a problem like this, we know we can either do cut and paste, right? So we can do cut solution. We can do cut or paste. Either way is fine. So let's do cut. Cut. Okay, so let's go with cut. So cut means we cut this irregular shape into a nice shapes that we know how to calculate. Okay, so let's do this. So first I get I can calculate, this is just 1. This is just 1/2, right? So this guy is, it's 1/2, it's 1/2. And this is also 1/2, and this is 1. This is 1/2. Let's recall that how we calculate the area of right triangle. This is 1, this is 1. So the area equals 1/2 times 1 times 1, which is 1/2, right? When you calculate the area of a triangle, don't forget the 1/2. That's because if you put two congruent ones, you just get a square. All right, so you get a 1/2, and this is also a 1/2, right? Okay, so now for this part, so this is 1 times 2. So this is, you get a 1, right? Because you have this right triangle. This is 1, this is 2. So the area equals 2 times 1 times 1/2. So this is 1, and this is also 1/2. Now let's figure out the area of this one. Okay. All right. So let me put it here. So the area of this. One way to figure out the area of this is we just use the base times height, right? Okay. So the base. So here the base is 1. So what is the height? The height is right here. So this is the height. The height is also 1. So the area is 1/2 times the base times height, which is again 1/2. Or you can do is you can just use the whole thing minus this part. So this is 1/2, and the whole thing equals to 1. So it's 1 minus 1/2 is also 1/2, right? So this part is 1/2. You can do the subject either way. So one way is, as I said, one way is you just use the formula. Maybe let me remind you. So if I have a triangle, general triangle, say this is ABC, right? So if this is the height H, and this is the base A, so the area is just 1/2 times the height times the base, right? So this is how we calculate the area. So for this, you can use this as the base, right? So this is the base. This one is the height, right? This is the height. This is the base. Or you can use you put the one back, you get a nice right triangle and the subtraction. Okay, now the point is, anyway, so the point is we get this is also 1/2. So I can just add them together, right? Okay, I have how many 1/2 do I have? I have 6 1/2, 6 1/2. I have 6 1/2, right? And then I have 2 more plus 1 and plus 1, right? So this, if you add up all those things together, I have what I get is I get a 5, right? So I get 5 because this one is 3. So 3 plus 2 is 5, right? So here I just do the go with the cut, and then you can try the paste by yourself, which means the paste means you calculate the area of those parts, and then you subtract that from the area of the whole rectangle.